Take a coin out of your pocket, spin it, catch it, and slap it down on the back of your hand. Before you look, cover it with a cup. Is it heads or tails? You do not know, but you do not doubt for a moment that it is one or the other. Under the cup, in the dark, the coin is in some perfectly definite state, and it has been since your hand came down. The not knowing is yours. The coin already made up its mind.
But if the coin is already settled under there, what is left for probability to even describe? Nothing is actually random anymore.
Watch. Bring in a friend. While you look away, they lift the edge of the cup, glance underneath, and set it back down without a word. Now ask each of you the odds. For you, still 50-50. For your friend, no odds at all. It is heads, plainly a settled fact. Same coin, same cup, same instant, two different numbers. Nothing about the coin changed when your friend looked. No force reached under the cup. The only thing that changed in the whole room was what one of you knew. So the 50-50 was never a property of the coin. It was a property of you, a fair summary of a mind holding two live guesses with no way yet to choose between them. What your friend gained by looking has a plain name: information. The coin holds a single piece of it, one yes or no, the piece engineers call a bit. And your uncertainty was nothing but the absence of that one piece. Hold on to this, because it is exactly what the quantum world is going to break. The thing is definite, the odds are about the knower, and information is closing the gap. Everything that follows is just that idea written as arithmetic. Call the two outcomes heads and tails, and give each a slot in a length 2 array. Your state of knowledge is a pair of non-negative numbers that add up to 1. How much of your belief sits on each outcome? 50-50 is the array holding 1/2 and 1/2. Let me draw that as a picture we are going to keep for the whole series. 1 bar for each outcome, and the height of a bar is how much belief you are placing there. 2 equal bars, each half of the full height, and together they fill it exactly. That filling is the rule. These heights are probabilities, so they are never negative, and they always add up to 1.
These look a lot like the amplitude bars from the series trailer. Are they the same picture?
Almost, and the gap between them is the whole point of this episode, so keep the picture close. For now, these are plain probability bars, just heights with nothing writing on top. When you are certain, the picture goes lopsided. 1 bar rises to the full height and the other drops flat to nothing. That all or nothing state is called 1 hot. All of the weight on a single outcome. The friend who peaked is holding one of these. And there is nothing behind the array. The distribution is not a blurry photograph of some hidden number. It is your state of knowledge in full. The coin is heads or tails underneath. Yes, but what you carry, and the only thing any operation is going to act on, is this little vector of what you know. If a state is a vector, then an operation on it is a matrix, and it acts by matrix multiplication. The simplest is a deterministic flip, the classical knot, which swaps heads and tails. As a matrix, it is just a single one in each column, sitting off the diagonal. Feed it a certain heads, and watch the 1 bar walk straight across into the other slot. Now a certain tails. But an operation does not have to be certain. A fresh fair toss throws away whatever you knew and hands back 50-50, no matter what you fed in. A worn, biased process might mostly keep the coin as it was and flip it only now and then, say 9 times in 10 it stays put. Both are matrices and both share one signature. Every column is itself a probability vector, non-negative and summing to 1. Those are the stochastic matrices. And they are exactly the operations that send a distribution to a distribution.
And if I run one after another, do I have to push the state through each step by hand?
You do not, and this is the payoff. Running one operation after another is just multiplying their matrices, which folds the whole pipeline into a single matrix, and that matrix is still stochastic. Toss the fair coin, then toss it again. Multiply the 2 fair matrices together, and the fair matrix comes right back, confirming what you already expected. A second fair toss changes nothing. That is the entire mechanics of classical information. States are vectors, Operations are stochastic matrices, and to chain them you multiply. There is one constraint underneath all of this, so obvious it is easy to walk right past, and it is the constraint the whole series turns on. The weights in these vectors and matrices are probabilities. A probability is a share of certainty, a slice of the whole, so it can sit anywhere from nothing up to everything, but it can never drop below zero. They are never negative, and they only ever add. Watch what that quietly forces. Suppose an outcome can be reached by more than one route, through some middle step. Start certain, branch through a fair stage, then recombine through a second one. Two separate paths now arrive at heads. Each path hands heads a piece of probability, a quarter from the one and a quarter from the other, and the total is simply their sum, 1/2. Picture the two pieces stacking literally. The second quarter lands on top of the first, and the bar grows taller.
So opening a new path can only ever make an outcome more likely, never less.
Exactly, and there is no escape hatch. Every contribution is at least zero, so opening a second route to an outcome can only raise its total, never lower it. Close one path and heads sits at a quarter, open the second and it climbs to a half. More ways to arrive means more chance of arriving. To make two routes work against each other, you would need one of them to contribute a negative weight, and a negative weight is not a probability. It is forbidden by the one rule. Probability piles up. It never digs a hole. Here is the hole crossing into the quantum world, and it really is this small. We spent this whole episode building the classical machine on purpose, so that the change would stand out cleanly against it. Keep the vectors, keep the matrices, keep multiplying to compose, change only that one rule. Let the weights be amplitudes, numbers that are allowed to carry a- sign, and you recover a probability only by squaring one at the very end. That single permission is the entire difference. Because now two routes to the same outcome can carry opposite signs. Classically, a half and a half pile up into one. But as amplitudes, a positive half and a negative half meet, and squaring their sum at the end sends the chance of arriving all the way to zero. Two ways to get somewhere, and you end up never getting there at all. That is the impossible sounding thing a classical coin can never do. The cancellation has a name: interference. And nearly everything strange in this series is this one move and nothing else.
That is the whole difference, a single minus sign.
That is the whole difference. Every vector stays, every matrix stays. We relax exactly one rule, the rule we just spent the whole episode making explicit, so that when the strangeness arrives you can see precisely what was given up and what was bought. The object that carries the change is the qubit, and building it is the next episode. It keeps the length 2 array, it keeps the matrix operations. So bring the coin, and bring your certainty about it. Next time, we let it go negative.